No. I sent you the syllabus for skeletal muscles. I'm saying
We had completed the muscles.
Yeah. I'm saying the syllabus for the homeostasis.
Yes. Okay. Send me the syllabus for the homeostasis.
Yeah, just 1 second. Just 1 moment.
You've sent it?
Yeah, I sent it for homeostasis. I'll send it for the glucose as well.
Let me see first. Okay, you have told me about the homeostasis in mammals involving physiological control systems and maintain the internal environment. The importance of maintaining a stable core temperature. The importance of maintaining a stable blood glucose concentration in terms of negative feedback.
And then here's the next part.
It is the next part you have sent to me. Okay, control of blood glucose concentration. Yes. Then control of blood water potential. Chalo. Anyway, let's do first the homeostasis. Isn't it? Hello? Hello?
Hi, yeah.
Yes, we start with the homeostasis.
Yeah, that's fine. And I don't mind, like, obviously, the little bit more detail is good. As long as I understand it. Yeah.
Yes. We come to that is homeostasis. We have already studied about the nervous system.
Yeah.
And the hormonal system.
Yeah.
These are the two systems. They control and coordinate the various activities in the complex multicellular organisms.
Yeah.
The organisms quickly respond to the environmental changes, using their nervous system. Using their nervous system.
Yeah.
Thus, the organism has to control their internal environment. Internal environment.
Yeah.
The maintenance of a constant internal environment is called homeostasis.
Yeah.
The internal environment, of the body consists of tissue fluids,
Yeah.
in which cells for nutrition and excretory waste are present. Are present. Are present. Thus, by maintaining the body fluids at optimum, or optimum means normal.
Yeah.
Normal levels. Normal levels. Protects the cells from the effect of external environment.
Yeah.
This is the general background of homeostasis. Now let us define what is homeostasis. Homeostasis. It is the maintenance of, you can write it down. It is the maintenance of internal environment. It is the maintenance of internal environment in the body of the organism.
Yeah.
In the body of the organism. It includes, what is this mean, the internal environment? It includes chemical composition, and then it includes blood volume, blood and tissue fluid. Blood and tissue fluid volume,
Yeah.
chemical composition must not change.
Mm.
Blood volume will be normal, should be normal. Tissue fluid volume should be normal.
Mm.
Homeostasis helps to meet the requirements of the cells,
Yeah.
so that they could function. They could function. They could function normally. Despite the changes in the external environment.
Yeah.
There can be there can be minor fluctuations such as changes in temperature, changes in temperature,
Yeah.
changes in pH, and changes in water potential. Changes in water potential.
Yeah.
Homeostasis brings these changes at normal levels and thus establishing an equilibrium in the body. You have to define homeostasis this way.
Yeah.
Now let us chart down the points, that importance of homeostasis. Importance of homeostasis. Number one. Number one. Changes in water potential in the blood and tissue fluids changes in water potential in the blood and tissue fluids may cause the cells
Thanks.
may cause the cells to shrink and burst as a result of exosmosis and endosmosis. Endosmosis means water will enter inside the cell.
Yeah.
Then definitely the cell will burst. By exosmosis, water will come out of the cell and the cell will shrink.
Yeah.
To maintain a constant water potential, constant blood glucose is essential. So that the glucose level does not increase or glucose level does not decrease.
Yeah.
Moreover, a constant blood glucose level keeps the cells to generate energy, by respiration. because glucose enters the glycolysis and then Krebs cycle.
Yeah.
Like this glucose, it will enter the glycolysis
Mm.
and then it will go for Krebs cycle. And ultimately energy in the form of ATP is produced.
Yeah.
Now, second point. It is the first point. Changes in water potential is maintained by homeostasis. Number 2. The enzymes that control the biochemical reactions are very sensitive to changes in temperature and pH. These changes reduce the rate of reaction
Mm.
of enzymes. Rate of reaction of enzymes. Even they can denature. Even they can denature the proteins and thus enzymes, because enzymes are made up of proteins. Even a small fluctuation means change. Even a small fluctuation can impair the ability of enzymes to carry out their normal functioning. To carry out their normal functioning.
Yeah.
Thus, we can write one line more. Thus, homeostasis maintains the internal environment so that biochemical reactions could occur at normal rate.
Yeah.
Point number 3. The cells that can maintain their constant internal temperature are more independent of changes in the external environment. External environment. Just here we have written cells. Now you write it here, the organisms. The organisms. Thus, they will have a wide geographical, thus they will have a wide geographical range for finding of food, for finding food and shelter. Food and shelter.
Yeah.
For example, we can take it from the mammals.
Mm.
Mammals. Mammals have the ability to maintain a constant temperature therefore they are found in different habitats like hot, deserts, cold climates, then frozen polar regions, because they have the ability to have a change.
Yeah.
You can see that mammals are found in water also. They are found in frozen polar regions also. They are found in deserts also, very cold regions also, hot climates also.
Yeah.
Now we come to how the homeostasis is controlled. That is the control mechanisms. Control mechanisms.
Yeah.
The control of any self-regulating system involves many steps. Number one, the optimum point. Optimum means normal functioning point.
Yeah.
Optimum point is monitored or monitored for the best functioning of the system. Number two, Optimum point number 2, receptors. Now, they detect any change from the optimum point this optimum point will be monitored by receptors. Now, third point, these receptors will inform number 1 is we have written it already, optimum point. Optimum point is monitored by receptors. We have written it. Now, third point. The receptors will inform. Receptors will inform the coordinator. Will inform the coordinator. Fourth point, the coordinator will send message to the effector. This effector may be a muscle or it can be a gland also. This effector will bring the change to the optimum point.
Yeah.
Now, what we have done, first, we must know the optimum point of the system. Optimum point. It will give a signal to the receptor. A receptor will inform the coordinator. Coordinator will inform the effector. Now, let us make a chart like this. Suppose there is a change in the system, change in system. What is the change in that system? Suppose that temperature falls down from 120 to 120 degree to, 20 degree to 18 degree centigrade.
Yeah.
This room temperature falls from 20 degree to 18 degree centigrade. Now this information will go to the receptor. Receptors. Now, information is carried that temperature is below the optimum point. Did you get it?
Yeah.
As it is given in your book also, like this. That now again it will go to the, it is gone this, it is gone this. It will go to the coordinator.
Yeah.
Now body will come to know that the heating system should be on. Right?
Yeah.
Then it will go to the effector. Now ultimately heat will come. Heat will be generated.
Yeah.
So this is called the all feedback mechanism. When heat will be generated, definitely the temperature will again come from 18 to 20 degrees centigrade.
Yeah.
This is called the feedback.
Yeah.
Just like our AC, suppose the temperature goes up, our body starts telling it that there is something wrong, temperature is high. We on the AC, then cool atmosphere will be created, and again the temperature will be maintained. This is called the now. The biological systems mainly use negative feedback mechanisms.
Yeah.
Negative feedback mechanisms. What is negative feedback? You can write it. It is the feedback. It is the feedback. It is the feedback when the change produced by the control system leads to a change in the stimulus detected by, just to make you understand what is it. Stimulus detected by the receptors and turns the system off. Now, what is it? For example, as I told you, suppose there is a blood glucose level. It increases in the body. Our receptors will tell that this has been sensed by the receptors. Every cell has receptors for everything.
Yeah.
Then they will inform the coordinator that how should it be maintained. Coordinator will give information to the effector. Now, as far as effector, the pancreas will produce more insulin. So less insulin. Because this time blood, now immediately the body will tell us within seconds, now I'm okay. As we take blood glucose level is low, we take a toffee in our mouth.
Yeah.
Immediately the glucose blood level will come at a normal path.
Yeah.
Those persons who are diabetic, they can immediately sense that now it is okay. This is called the negative feedback, because they have switched off the point due to which the trouble was there in the body.
Yeah.
Did you get it?
Yeah.
Now we come, this is the negative feedback. Now we come to the positive feedback. Positive feedback. Just I want to take water. Now we come to the positive feedback. Positive feedback is that type of feedback when there is greater deviation from the normal. I make you understand what is it from the normal. Now suppose there are neurons. Suppose there is a small influx in sodium level increases, influx in sodium. Influx in sodium. It will increase permeability of the neuron for the sodium ions.
Yeah.
Causing a further increase in permeability for the ions. Now just let us make it in short. Just understand it. As we took the example of blood glucose. Blood glucose has increased.
Yeah.
By any means, blood glucose level increases when insulin is low.
Yeah.
Is low. Suppose we give a patient the insulin in any way, immediately the blood glucose level will decrease.
Yeah.
We have come to the normal. This is the negative feedback. Glucose had increased, but we have decreased with this.
Yeah.
It is the negative feedback. Now we come to the positive feedback. Suppose neurons. There is permeability of sodium and potassium ions.
Yeah.
If we put more sodium in the body, then its permeability will not decrease. It will rather more increase. Got my point?
Yeah.
For example, we give a slap to a person for anything. he starts misbehaving more than earlier.
Yeah.
That is positive feedback.
Mm.
Suppose in this case, we show the eyes to the person. He stops doing nonsense things.
Yeah. Yeah.
Did you get it?
Yeah.
You can see it. If you're not understood, tell me.
Yeah, no, I understand.
Now you understand.
Mm.
Then this control system of the body, this control system of the body. Suppose one more example you can take. Suppose there is cold. Our skin receptors will come to know. Skin receptors will come to know.
Yeah.
And we will definitely know that the temperature should be raised.
Mm.
Is to be raised. Who has told us that temperature is to be raised? Body mechanism, receptors, coordinators, effectors.
Yeah.
They have told that's why we will raise the temperature.
Mm.
Temperature is to be raised.
Yeah.
Otherwise, we will not come to know.
Mm.
Got my point?
Yeah.
Then it is decided by the brain what to do and what action should be taken.
Yeah.
I think this is all about your homeostasis. Now you can just read it in your book, in your copy, then we will do it more.
Yeah. That is, makes sense. Hey, so I understand the concept of the positive feedback, but I don't understand the example. How does the increasing the sodium ion increase the permeability? Why would it increase the permeability?
I tell you.
Yeah.
Nerve impulse is what? It is the nerve membrane. Sodium ions are outside, potassium ions are inside.
Yeah.
There is going, as we studied the this resting potential, action potential. Yeah? And potassium will come, this potassium will go out, sodium will come inside.
Yeah.
If we increase the sodium ions, some sodium increases, sodium level increases in the body.
Yeah.
It does not mean that they will stop going inside.
Oh, okay.
They will
Yeah.
increase more and more.
Yeah, that makes sense. Because there's less inside the membrane.
Yes, inside the membrane.
Yeah. Oh, okay. Yeah, that makes. Yeah.
Got it?
Yeah.
Now our next case is, I think, negative feedback. We have done at the possession of separate mechanisms. We have done. Students should be able to interpret information. This is okay. Now we come to the that your control of blood glucose level.
Yeah.
You
know?
Now, this blood glucose level, blood glucose level in the body is maintained by hormones. Hormones.
Yeah.
These hormones are insulin and glucagon.
Yeah.
Insulin decreases the sugar level and glucagon increases the sugar level.
Yeah.
But this is maintained by neurotransmitters also, neurotransmitters. These are the chemicals which are secreted by the nervous system,
Yeah.
neurotransmitters, as these are secreted by the endocrine glands.
Yeah.
This is by the nervous system, neurons.
Hmm.
Both these collectively interact with each other to bring homeostasis in the body.
Yeah. Hmm.
Now, how these hormones act? The glands which secrete hormones, they are called the endocrine glands.
Yeah.
These hormones are secreted directly into the blood.
Yeah.
Directly into the blood.
Hmm.
Then these hormones are carried to the target cells, target where they have to act,
Yeah.
target cells. These target cells have specific receptors. Specific receptors.
Yeah.
Specific receptors for those hormones.
Hmm.
And moreover, we know that hormones are effective. Hormones are always effective in low concentration. And have long lasting effects. Long lasting effects.
Yeah.
There are so many mechanisms for the hormone action, but one mechanism for hormone action is second messenger model.
Yeah.
This model involves the working of two hormones. One is adrenaline and second is glucagon. This adrenaline is secreted by the adrenal medulla. Adrenal gland, the medulla part of the adrenal gland.
Yeah.
This glucagon is secreted by the alpha cells of islets of Langerhans.
Yeah.
Did you get it?
Yeah.
Now, how this adrenaline works? Suppose this is the cell. This is the receptor for adrenaline on the surface of the cell. This adrenaline binds with, this is called the receptor.
Yeah.
Suppose this is the liver cell. Number 1 point, adrenaline binds with the receptor present on the surface of the liver cell. Adrenaline. Second point. What is this receptor? Receptor is a protein.
Yeah.
When it binds, this it changes the shape. It changes the shape. of the protein on inside the membrane. Did you get it? Adrenaline from the adrenal medulla that comes and binds with the receptor protein of the liver cell. It changes the shape of the protein. Right? On the inside of the, this inside.
Okay.
Now, third point.
Yeah.
When the shape has been changed, it activates the enzyme adenyl cyclase. An enzyme adenyl cyclase.
Yeah.
What will it do? Adenyl cyclase will change ATP into cyclic AMP, adenosine monophosphate, or we write it like CAMP. Which is the second chemical messenger we call.
Second, what did you say is the second?
This is second chemical messenger. I just write it in the next point.
Yeah.
CAMP is called the second chemical messenger or second messenger.
Yeah.
Now what will happen? Next point. This CAMP binds to the enzyme, kinase.
Yeah.
What will it do? This active enzyme, it catalyzes the conversion of glycogen, because food is stored in the form of glycogen,
Yeah.
into glycogen to glucose.
Yeah.
It moves out of the cell. Which moves out of the cell. Cell means liver cell.
Yeah.
And then it goes into the blood. And as a result, the glucose level increases.
Yeah.
Did you get it?
Yeah. Right.
Just look into your copy and then ask me these 5 points.
Yeah. Wait, so is glucagon? Hello?
Just wait. I'm coming for within half minute.
Yeah, okay. What was I going to ask? Yeah, so is glucagon not involved in this?
I tell you. We have just taken the example how the adrenaline and glucagon increase when sugar level decreases,
Yeah,
how they increase the sugar level
yeah,
by the activation of enzymes. Then ultimately glucagon, what will it do in the liver cell? Stored glycogen will be converted into glucose.
uh-huh,
Glucose will come out of the cell
yeah,
and will come to the blood,
yeah.
and the level increases.
So is the glucagon in the liver cell?
Yes. This is synthesized over there.
Oh, okay.
Glucagon is a hormone which is synthesized by the alpha cells of the pancreas.
Yeah. Wait. 1 second. Wait, so in the steps you showed me, like the
Okay.
1 to 8 step,
Uh,
1 to 8 steps.
read
So
it.
is it like saying adrenaline or glucagon can act as the first messenger, or is it like
No, glucagon is not a messenger. Glucagon
uh-huh,
is a hormone.
yeah,
Messenger is something which gives the message that do this way.
yeah,
Glycogen and this glucagon is under the control.
yeah.
It will just change glycogen into glucose.
Okay. Uh-huh. Okay, and that's sped up by the kinase.
Yes.
Okay.
These are
Yeah.
the two enzymes involved. One is the adenyl cyclase. Adenyl cyclase.
Hmm.
And second is the kinase.
Yeah.
Now, when will you give me the time?
Should we do Sunday?
Sunday is okay.
Yeah. What do I want to get through for Sunday? Yeah, we'll do Sunday, and I'll see during another day during the next week if I can do another lesson.
Okay.
But we'll
Then let
keep
it
Sunday
be.
down.
Then Sunday, then Wednesday.
Yeah, okay then. I'll try Wednesday as well.
Keep every Sunday and Wednesday till your exams.
Yeah, okay then.
Isn't it? Now you look into
Yeah,
a copy if you have not understood anything.
yeah. Wait. Yeah, I think it's fine.
It's fine.
Yeah.
The next part, we will be doing the role of pancreas.
Yeah, that's okay. Can we go also next week, the next lesson over the? Oh yeah, wait, the roles of yeah. Wait, the roles of pancreas or the roles of
Yes,
liver?
yes, yes, yes.
Uh,
This
because
is
I
the
want to
role of
go.
adrenaline.
Yeah. Okay. Yeah. Yeah, that's okay then. Yeah.
Then anything else? Anything new about your Manchester, London?
Oh yeah. I got an offer for Sheffield
Okay.
for dentistry, so I've got a place now.
Okay.
So all I need to do is get the grades for the offer, and then I start in September.
Oh, wonderful. Wonderful. Wonderful.
Yeah.
Wonderful.
Mm.
Wonderful. Then we will come to England to congratulate you.
Yeah. Yeah.
Okay, then bye.
Yeah. Bye. Thank you.
Okay.